Okay, so this lesson is on right triangle trigonometry. So this is the first lesson in the Unit 9 Trig unit, which is Unit 9. And so for the first day in 9.1 or day 1, it's really just a review of geometry. We're just making sure everybody's sort of got their trig ratios and how to find sides and angles. Some of the stuff, a lot of the stuff you learned in geometry is making sure that everybody has the right idea and what to do before moving on. Because you're going to have that sort of stuff mastered, your basic trig functions and trig ratios. You're going to have those sort of mastered in order to move forward. So basically, trigonometry, if you break down the word, trigonometry means basically the measurement of triangles. So the sort of MET here means to measure. And so it's the measuring of triangles. And so basically what we're going to learn how to do is what we say when we say solve a right triangle. So in order to solve a right triangle, like this is an example of a right triangle, it's finding all of the sides, the values of all the sides, and the values of all the angles. Now, being that this box is right here, denotes that that's 90 degrees, which makes this a right triangle. You'll always have some sort of what we call reference angle, which is what this theta is. Theta represents the measurement of an angle, and from that reference angle we can find all of our pieces. The side that is always opposite of the reference angle is called the opposite side, or what we'll refer to as O. The hypotenuse is always opposite the right angle. Okay, now it might not look like the longest side, but the hypotenuse is the longest side, and it is always opposite your right angle. So we refer to that as H. You'll see that represented as H. And then the adjacent angle is the side that's next to the reference angle, but not the hypotenuse. So that's this side here, which we refer to as A. So when we are writing our basic trig ratios, they are in reference to these opposite, adjacent, and hypotenuse. If you remember from geometry, you had this sort of phrase, SOHCAHTOA. Where the ratio of sine can be found in reference to opposite and hypotenuse. The cosine is represented by adjacent and hypotenuse, and tangent is opposite and adjacent, and they're in ratios. So sine, we'll start with sine first. Sine, being that it's OH, sine of theta equals the opposite over the hypotenuse. Now, I'm not sure if you guys learned this in geometry, but cosecant is the inverse of sine. You should have learned that cosecant is the inverse of sine, and all that really means, cosecant is written as CSC, that represents cosecant of theta, is remember, it's the inverse of sine. So basically the ratio is flipped. So you have H over O. Now this is a tricky one. So oftentimes kids think that cosecant is the inverse of cosine, and it's not. You have to really train your brain because it's really easy to think cosine and the inverse is cosecant. So the way I always sort of remembered it is the opposite of sine seems like it would be secant, but I know that it's not. It's the opposite one of that, and that's cosecant. So however you want to remember that, sine's inverse is not secant, it's cosecant. Okay, so that's always a tricky one. Cosine of theta is AH, or adjacent over hypotenuse, which means that secant, which is written as SEC theta, is just the inverse, of H over A. And tangent, this is the only one that's sort of consistent, but tangent of theta, OA, means opposite over adjacent. Its inverse being cotangent, COT, of theta, is just the inverse or opposite A over O. Sorry, that's not on the screen. So that is that. So what we're going to do now is use our knowledge of these trig ratios to find the values of an actual triangle with actual numbers in it. So this says to find the 6 trigonometric ratios, which is really you're just finding 3 and then flipping them to find the inverses here. Give the exact answers and round the answers to 4 decimal places. So we are given a reference angle here as theta. So that means that the 8 will represent O because it's opposite. This will represent H. And this will represent your adjacent. Now the only issue here is that we have the opposite in the adjacent when we don't have the hypotenuse. Now it shouldn't take you too long to figure out how, if I have this side and this side, how I figure out the side of the hypotenuse. Most kids generally remember Pythagorean theorem, which is the a squared plus b squared equals c squared. So what we're going to do, we're going to find the hypotenuse first. So a squared plus b squared equals c squared. 15 squared is 225. 8 squared is 64. So I end up with 289. And then the square root of that ends up being 17. So my hypotenuse equals 17. So now I have all the sides, and now I can figure out all the trig ratios. So sine, since it is opposite over hypotenuse, I just replace now opposite is 8 and hypotenuse is 17. So 8 over 17. And so if we convert that to a decimal, to 4 decimal places, if you do 8 divided by 17, you get 0.4706. Cosine is adjacent over hypotenuse, which if I use the adjacent 15 over 17 and divide those, I get a decimal of it's 0.8824. And then tangent, being opposite over adjacent, is 8 over 15, which divided is 0.5333. Now what's nice is once you have the original trig ratios, sine, cosine, and tangent, to find the inverses, cosecant, secant, and cotangent, it's just flipping of the fractions. So instead of being 8 over 17, it's 17 over 8. Instead of being 15 over 17, it's 17 over 15. And instead of 8 over 15, it's 15 over 8. And we can find those decimals as well. 17 over 8, rounded to 2 decimal places, you actually only need 3 because that's an exact decimal. And secant, 1.1333. And cotangent is 1.875. Again, you don't need a 4th decimal place because it's an exact decimal. So there's all your trig ratios converted into decimals. Okay. So basically, what we've learned here with cosecant, secant, and cotangent is that cosecant, secant, and cotangent are inverses of each other. In other words, if I wanted to find cosecant theta, I would just do 1 over sine theta. And if I wanted secant theta, I would just do 1 over cosine theta. And if I wanted cotangent, I would do 1 over tangent theta. They're inverses of each other. So it's 1 over that value. Now going on to the other side, we're going to actually construct some triangles here. So it says let theta be an acute angle of a right triangle. Evaluate the other 5 trigonometric ratios if sine of theta is 7/10. So the first thing we do obviously is draw a triangle, and it's a right triangle, so it's a pretty basic. So I'm going to draw my right triangle. Okay, the box here, it's a right triangle. And I have theta, so I have to put a reference angle somewhere. Now it doesn't tell me specifically where it is, so I can put it at either up over here or down over here. So I'm going to just put it, I like it keeping it on the bottom, so I'm going to do down over there. And then use this as my reference angle to do the sine, cosine, tangent, and so on. Now, it states that sine of theta up here, sine of theta is 7/10. So that tells me something. The fact that the sine is 7/10, since sine is opposite over hypotenuse, tells me that the opposite side is 7 and the hypotenuse is 10. So what this means is this is 7 and this is 10. Now to find the adjacent side, I just do what I previously did, which is to do Pythagorean theorem. A squared plus b squared equals c squared, and I'll spare you the work. I feel like you could probably do that, but if you do it correctly, this side ends up being 7.14. Okay, so now I'm going to make all of these ratios. Well, I'm not going to do all of them. I'll give you to do some of the work here. But basically, we're going to do exactly what we just did in the previous problem. So we have sine theta, cosine theta, and tangent theta. From our reference angle, sine was already given to us as 7/10. Okay. Cosine theta is adjacent over hypotenuse, or 7.14/10. And tangent is opposite over adjacent, or 7/7.14. And you can convert those to decimals if you want, or just leave them in fraction form. It doesn't really matter. Honestly, you're probably not going to be converting these to decimals in real problems. You'll probably just keep them in fraction form. It's way easier and more accurate to keep them in fraction form. Now I'm going to spare you the work again here. I feel like you can do cosecant theta since all you're doing is just flipping the fractions. Well, I'll just do it. Secant theta is just the opposite, so 10/7.14. And then cotangent of theta is 7.14/7. So, solving right triangles. When you solve a right triangle, and this is what I mentioned in the very beginning here, when you go to solve a right triangle, essentially you are going to find all angles and all sides of a triangle. Okay, so you're going to be finding all missing measures, and that is angles and sides. Okay. So in this first problem, we are given an angle here. We are given a side here. And you probably may have missed this, but we're also given, obviously, the fact that it's a right triangle. You're given that angle there. So in this particular problem, we're given 2 angles and a side. So that makes this over here theta. You are always going to be given 2 angles and a side, or 2 sides and an angle. You are always going to be given 3 of them. Since there are 3 angles in a triangle and there are 3 sides to a triangle, you only need to find 6 measures. And you're already given 3 of them, always. So I already have angle B is 68 degrees. I already have that angle C is 90 degrees. So all I need to do is find angle A. On this, in terms of sides, I have A equals 5, so all I need to do is find B and find C. So here are my three missing values. Now the question is, where do I start? Okay. Well, you're going to want to start with the, in terms of angles or sides, whatever one you have two of. Since I have two angles already, it's really easy to figure out the third angle because all angles of a triangle should add up to be 180 degrees. So if I know the first angle and the second angle, I can just do a little bit of addition or subtraction to figure out this third angle. So if I do 180 degrees and subtract 90 and subtract 68, it gives me that the remaining angle is 22 degrees. All right, one down, two more to go. Now, unfortunately, with the sides, I cannot use Pythagorean theorem because I only have one side. So I have to do a little bit of trig to figure out at least one more side. Now, I'm going to recommend that you do not use the new angle you found. Use the angle that was already given to you. Since this is 68 degrees, I can use multiple trig ratios to figure out either of these sides. Okay, I'm going to go for side B first. So if I want to find side B, and I know side A, and this is my reference angle, what trig function is opposite and adjacent? Okay, opposite and that's tangent. So I can just do tangent of 68 equals opposite, which is B, over hypotenuse. Or sorry, adjacent. Opposite over adjacent. Now the reason why you wouldn't want to use B and C is because you don't know either of those sides. So because I'm given side A, I want to use a trig ratio that includes the adjacent side. Since this is my reference angle, I want to include the adjacent side. So I'm going to use some form that includes adjacent. So I could have used cosine too, and used this over this to find the hypotenuse. But since I'm finding this B, I'm using opposite and adjacent, which is tangent. So we're going to do tangent of 68 degrees. Now, here is where you're going to want to use your calculator, but we don't want to go too much here. So first thing we need to make sure is that our calculator is in degree mode since we're dealing with degrees. And how you do that is you hit mode, and you'll see here that degree is selected. If you're on radian and radian is selected, go over to degree, go down here, and just make sure that degree is selected. Once degree is selected, I can then do tangent of 68 and get that value there. Now, I'm going to keep this in my calculator. I'm not going to clear it or do anything, but I'm going to write just for reference that tangent of 68 is about 2.475 equals B over 5. Now, to solve for B, I would need to get rid of the 5. Get rid of the 5, I can multiply both sides by 5 to do that, and B will equal whatever that is. So now that I've saved this in my calculator, I can just hit times 5 equals. And I get 12.375. Or if we want to round, 12.38. Almost done. I only have one more. Now there's a couple ways you could go about doing this. I could do the other trig ratio, 12.38. I could use the other trig ratio, so just do cosine of 68 is 5 over c and work backwards, or I could just use Pythagorean theorem. What you're going to want to do though is make sure that this number is still in there, because I don't want to round it. That's going to make your answer slightly off. So I can use that as one of my sides. Since that's side B, I get to do that squared plus 5 squared equals and then just take the square root of that number. Square root of that number is 13.3, around to 13.35. And so now I have all 6 of my trig ratios. So I'm going to not do number 4 here. We just did number 3. Number 4 is exactly the same process. They give you 2 angles and a side. Find the third angle from the third angle. Use trig ratios to find the other 2 sides. Now, I am going to do 5 here because it is slightly different and it does throw kids off. Oftentimes when the triangle is like upside down like this, kids often mistake the hypotenuse and the sides for the wrong thing. If you always just remember that the hypotenuse is always opposite your right angle, okay, this will be your hypotenuse, then you shouldn't ever get that wrong. So what this type of problem gives you is only one angle, being the 90-degree angle. It does not give you the other 2 angles, and it gives you 2 sides. So remember what I said in the previous problem. The way to start these problems is to always just finish whatever has the most information, so angles or sides. In the previous problem, they gave us 2 angles and 1 side, so we just completed the angles. Since we know that all angles add up to be 180 degrees in a triangle, we found the third angle that way. For this one, since we only have 1 angle, we can't do that, right? So, but we do have 2 sides, and so knowing 2 sides of a triangle, we can find the third side using Pythagorean theorem. So I'm going to do that real quick. We don't have the hypotenuse, so we do have 13 squared plus 4 squared will equal c squared, and that is 169 plus 16 equals c squared, which is 185 equals c squared. And so we square root, and this is not going to be a nice clean number, but the square root of 185 is 13.60, so 13.6. So c will be 13.6. So I found one of my sides. So all I need to do is find this side here, which is side AB, which I just did. That's 13.6. 13.6. I need to find angle A, and I need to find angle B. Now, in order to find these angles, I need to use trig ratios. Because I have all the sides and I have a reference angle here, I'm going to go ahead and find angle A since it's already got the theta as my reference angle. Now, so I can use any of these sides, though, just like in the previous problem, you're going to want to go with what information is given to you. You don't want, because this answer right here was rounded, we don't want to use the hypotenuse when calculating the other angles, because this is an estimation of that side length. So I'm going to use the sides that were given to me. In reference to this angle here, I have the opposite side and the adjacent side. So opposite and adjacent is tangent. So I'm going to do tangent of theta equals opposite 4 over 13. Now, I'm not sure if everyone has done this type of trig problem here. So what makes this different than the previous problems is I don't have the angle, but I have the sides. And this is where we need to go backwards. And so if you remember, or maybe you don't remember, maybe you've never seen this before, but you should have seen these little trig inverses here. So we have sine, cosine, and tangent, but above the sine and cosine and tangent, you have sine to the -1, cosine to the -1, and tangent to -1. These sine or trig inverses are used when you have the sides but you don't have the angle. So you're going backwards. Whereas the big button sine, cosine, tangent are used when you actually have the angle. So in order to find the tangent of theta, or to find theta, so essentially I'm finding theta or angle A, I am going to use that tangent inverse, and this is how it works. So I go second and then tangent. It gives me a little tangent inverse. No matter what calculator you have, this is what's going to happen. Now, if you have the fancy calculator or the newer calculators, you can just do alpha y equals and put in a fraction. But if you have an older model of the calculator, you'll just simply do 4 divided by 13. And hit equals. As long as your calculator is in degree mode, that's what it should. I don't know why it would have switched to radian, but this answer is going to be in degrees. So 17.1 degrees. What that means is that angle A, which is what the angle I was finding, is 17.1 degrees. Now that I have the 90-degree angle and the 17.1 degree angle, I could just simply subtract them from 180 to find the last one. So that's what I'm going to do. I'm going to do 180 minus 90 minus 17.1, and that'll give me my other angle of 72.9. So 72.9 degrees. And so now I have the 3 missing pieces to my triangle. I was given this side, and this angle, so those are the 3 missing sides. And number 6 is exactly the same as this, so if you want to try it out, you can practice it if you want to. That is solving triangles. Ultimately, on a quiz or a test, this is what the problems are going to look like, so make sure you know how to do these. Thanks.